If the robots take over, what would our biosignatures look like? Is a galaxy's rotation tied to its black hole? What would happen to the universe if dark matter disappeared? And in Q&A Plus, which sci-fi universe would I want to live in? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Arias, third of his name. Say we're wiped out by AI. What would Earth's new biosignatures look like? See, now you're thinking like an astronomer, right? Like this is the kind of question you say, okay, we are now developing artificial life forms, theoretically, right? We're making data, and who knows how this ends. But let's imagine it ends badly. Let's imagine that instead of us successfully navigating this, or the AI just doesn't work out and we destroy all of the computers and we don't worry about it. What if the AI is successful? What if the AI overthrows humanity? What if, right? Well, then what would you see? You make a hypothesis. You say, well, I wonder what we would see if the AI overthrew its world. Well, then you would probably see a Dyson sphere or some version of that. You would see some excess in infrared radiation coming from the environment around a star. Human beings, we are very fragile. And so going to space is a very difficult thing. We have to take our entire ecosystem with us to be able to fly to space. The robots don't. Maybe they'll need a little bit of radiation hardening, but apart from that, they're ready to go to space. And so once they go to space, they're going to get their hands on the raw resources, the asteroids, the comets, the planets. They're going to get their hands on the energy that's coming from the star, from the sun, and then they're going to make things. And those things will absorb energy from the star, and then they will re-emit in infrared, and it will create an ever-growing infrared signature around that star. And eventually, if our telescopes are good enough and we understand what it is that we're looking at, then we might say, oh, there could be some kind of civilization at that star. We wouldn't know if it was life forms, biological life forms, or whether it was some kind of artificial life form, until we, were able to watch it farther. If we knew like how quickly this thing happened. The other thing is that you can imagine once some advanced civilization makes structures and puts them in space, that if they're lined up between you and that star, then these things are going to pass in front of the star and they're going to have a weird shape. So like a triangle or some kind of weird big space station. And that dip in the light as the object is passing in front of the star from our perspective, that would be something that we could tell. And in fact, we can know that right now today. Like if we just looked at the light curve of a star as a triangle was passing in front of the star, it would give a bizarre shape to the light curve. And we would know right away that there's something unusual there and a good place for follow-up study. So unfortunately, we wouldn't know right away whether it was biological or artificial life forms that actually made these structures, but if the speed is happening, and then you can sort of imagine, there's this idea of the grabby aliens. And you talked to Robin Hanson about this idea of the grabby aliens, that while most civilizations are going to be slow, or maybe just want to stay home and just chill and relax and not be grabbing all of the universe, there will be some subset, some small group, the Borg, who are going to want to go for it and grab it all. And that you would then watch those structures that you saw, suddenly you notice there's like 5 stars that are grouped together and they all have weird transits, or they all have strange infrared glows around them, that there was an empire forming around that group of stars. But the crazy part about that is that it makes sort of almost as much sense to expand at the speed of light. Like once you can do this, then you just start expanding at the speed of light, or almost the speed of light. And so we would detect the presence of an advanced civilization that was trying to accumulate as much material as it could in the universe moments before it arrived. We'd have like almost no notice, and then suddenly that civilization has swept past us. So, how do we know that we detect the robot civilization? Because their spaceships are here in the solar system and they're beginning to dismantle planet Earth for their Dyson spheres. Frosty Winnipeg, is the rotation of a galaxy tied in any way to the rotation of its black hole? No. the orientation of the spin of a supermassive black hole that's at the heart of a galaxy is not connected at all to the rotation of the galaxy itself. And in fact, astronomers very recently were able to work out the orientation of the supermassive black hole at the heart of the Milky Way. I forget the exact angle, but it is not lined up perfectly with the rest of the galaxy. Now, it can be, and I don't know what sort of percentage, figuring out the spin rate of a black hole, the orientation of a black hole can be very difficult unless it's actually putting out jets of material. Once you get the jets come from the poles of the black hole, and that tells you the orientation of the black hole in the galaxy. And it often lines up perpendicular to the spin of the galaxy, but it doesn't have to. Black holes have a destiny of all their own. It's time to shout out our new patrons at the $5 level and above. Aaron Hoogstraten, Eli Whitaker, Martin Hovorka, Victor, Chris Sweet, Tito, John Aaron, Derek Porter, Aberlaw, and Alan Scott. Join a community at patreon.com/universe today. Ed Skeptic, if all the dark matter in the universe disappeared, what would happen to the normal matter? Oh, that's a great question. So we couldn't work back from the various things in the universe. So the first thing is that we know that dark matter exists because of a series of observations. So the first observation is that you measure the rotation curve of galaxies, and they are rotating too quickly for the matter in the galaxy to hold that together by gravity alone. And so if you remove the dark matter from that galaxy, then the galaxy would have to make sense again. So it would be rotating at a speed that did not exceed the amount of mass that was in that galaxy. And you look out into the universe and you'd measure the rotation rate of every single galaxy out there, and you would say, they all rotate exactly what you would expect. I see the stars, I count the stars, I estimate the mass of the galaxy based on the stars, I estimate how quickly a galaxy should be able to rotate based on the number of stars, and that looks normal to me. So, the law of gravity, as we understand it here on Earth, also seems to apply to galaxies that are really far away. The second observation is the paths that the stars take inside the galaxy itself. So when you think about the solar system and you have the sun at the center and you have the planets that are going in orbit around the solar system, the closer the planet is to the sun, the faster it goes in orbit around the sun. And then as you move farther and farther away from the sun, then their orbital speed slows down. So Mercury is like 48 kilometers per second. The Earth is 30 kilometers per second, and Neptune is like 5 kilometers per second. And that is what gravity predicts you would see. And so once again, when we look at distant galaxies and we measure the movements of the stars in the galaxy, when they're very, very close to the center of the galaxy, they do this. They move very quickly. They work as expected. But once you get a little bit far away from the galaxy, the stars all go the same speed. So instead of the closest stars going, say, 300 kilometers per second, and then the stars farther away going 100 kilometers per second, and then when you're way out in the boondocks of the galaxy, the stars are only going 10 kilometers per second. That's not what you see. You see, in the Milky Way, for example, the stars are going like 220 kilometers per second. And they're doing that from almost at the center of the galaxy all the way out to the outskirts of the galaxy. And so if you removed all the dark matter from the galaxy, then the stars in the galaxy would behave exactly like planets do in the solar system, which would be very interesting, right? So you would measure the speed and you'd be like, yeah, the galaxy is like a big solar system. I measure the stars, the ones that are very close to the center of the ones that are going around really quickly, they're going incredibly fast. And then the ones that are really far out, they're going very slow. And so that's what you'd see, but that's not what we see. And then there's other stuff. And I'm less specific sort of thinking about this, but essentially, when you measure the concentration in the cosmic microwave background radiation, you have to have dark matter to be able to have the kinds of concentrations that you see. And there are other independent measurements that have been made for dark matter. So, each time you removed dark matter from the equation, when you made the observation of the thing, it would behave exactly as you were expecting. Right. And so that's why dark matter is this collection of observations. That you look at the spin of these galaxies and they don't move as you're predicting. You look at the movement of the stars inside these galaxies and they don't work like you're predicting. You look at the cosmic microwave background radiation and it's all messed up. You look at the concentration of galaxies, the large scale structure of the universe, and there's like more to it. Gravitational lensing, right? Gravitational microlensing, where you look at the light of all of the stars that are really far away. When we look at it with telescopes, all of the light is slightly distorted, right? That the light is following this weird wavy pattern as it's making its way to us. And if you removed all the dark matter from the universe and you looked out into the cosmos, all of these distant galaxies would be perfect. You wouldn't detect any of this weird waviness. Everything would just be perfect and pristine, and the light would be clear, and it would not deviate at all from the path that it was taking. So the universe would look very different if you removed all the dark matter from the universe. And so the fact that we see this weird universe tells us that there is more to the universe than we understood. Christian Desailliers, what do you mean when you say material must shed its angular momentum before falling into a black hole? It's the exact same thing as orbiting around the sun. The Earth is orbiting around the sun right now. It's going 30 kilometers per second in orbit around the sun. That's why the Earth doesn't fall into the sun. It is in orbit, and so its orbital speed is a balance against the gravity that is pulling it. Was it a centripetal pseudo force outward that is balancing the force of gravity that is pulling inward? And so Earth is in perfect balance. It's going in orbit around the sun. And so when material is trying to make its way, or gets too close to a black hole, then it can join the accretion disk that is around the black hole. And this thing is spinning, right? In some cases, it is spinning very, very quickly, depending how far away it is from the actual black hole. And the black hole's gravity is what sets these orbital rates. And how does it actually fall in? That's one of the challenges that astronomers are trying to deal with. Now, there's a couple of sort of interesting things that are at play here. So these particles, they're bumping into each other, right? They're jostling around as they're going around in the accretion disk. And so what that does is that causes some particles to lose a little bit of their orbital speed. And when you lose your orbital speed, you fall closer to the thing that you're orbiting. So when a satellite is going around the Earth, and it fires its engines in the direction that it's going, then that slows it down. And what that causes it to do is lower its orbit to get closer to the Earth. Now, in the case of the Earth, we've got the atmosphere. The closer you get to the Earth's atmosphere, then you start to burn up, right? But there is no atmosphere around the black hole, but there are tidal forces. There are, various radiation pressure. Lots of stuff is going on around the black hole. And so you need some mechanism that is causing this to happen. And there's a bunch of other mechanisms, something called the Kozai mechanism, where essentially you can actually crash like highly elliptical material that's on a very sort of an orbit that is not lined up with the orbit of rotation of the thing, can sort of transfer that its tilt for eccentricity and cause it to crash in. So you can have like highly elliptical comets will crash into the sun, and asteroids and things like that. And so just all the stuff is going around the black hole really quickly. It's got to shed that momentum before it can finally go into the black hole. And, for the longest time, there was a big issue with supermassive black holes called the final parsec problem, which is like you've got lots of material that's going around the black hole, but what puts it into orbit and allows it to actually make its way all the way down into the black hole? There's sort of another idea about this is we always talk about the sun is the hardest place in the solar system to get to, which sounds really strange. People always say, all you got to do is just drop things and they fall into the sun. But remember that anything that you're dropping from the Earth has the same orbital velocity as the Earth. It's going 30 kilometers per second around the sun. And so to actually make something fall into the sun, you have to cancel that 30 kilometers per second. You got to have it going 0 kilometers per second. And that requires a very powerful rocket. And so you have to give the material going around a black hole the equivalent of a very powerful rocket for it to be able to actually make it down into the black hole. Big C799. If the universe could somehow magically answer any question, what 3 questions would you ask? Oh man, easy. Are we alone in the universe? Right? And like, I want specifics. Like, don't just say yes or no. Although if I say yes, okay, then we're alone in the universe, that gives me the answer. But if it's no, then I want details. I want specifics. Where did the universe come from, right? Why is there something and not nothing? I would love to know the answer to that question. And then I would want to know in detail the best way to be able to fly from star system to star system. Like, I want the plans. I want the theoretical ideal system for traveling from star system to star system. I want the design so that we can eventually build it. That's what I would like. I don't want to be able to understand it. It's not like a monkey's paw. Turkey's a little dry. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And we call it Q&A Plus. This week's bonus question, which sci-fi universe would I want to live in? And I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live show. Now, we've got a very exciting anniversary that has happened, and I want to talk about how you changed my life and changed my business. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barely Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bailout, Cooper Nelly, Darkfinger, David Gilton, David Matz, Evan.pro, Greg Feely, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, One Step for Animals.org, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Found Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So it's been about a year since I made my desperate we have to talk plea to you to help me save my business. And that was that the advertising revenue that we have been getting had just been steadily declining. It was down like 80% from where it was at its peak. And so I was having to start making some very serious decisions about whether or not I would have to start laying off people and how I would sort of roll up Universe Today into a smaller version of itself, which sucks. But I decided, you know what? We've been having a really good time with the patrons so far. It's moving in the right direction. So I'm going to remove all of the advertisements from the Universe Today website, all the ads from the newsletter, all the ads from the podcasts, minimum ads here on YouTube, and switch to being funded entirely by the patrons. And here we are, 1 year later. The response immediately was incredible and closed the gap and made it so that I didn't have to make any of those tough calls, which was fantastic. And then I was sort of expecting there to be this quick drop off of the people who, wanted to be there to help support us, but, couldn't afford it on a regular basis. And what we found was that the total number of patrons kind of stayed roughly the same for an entire year, which has been amazing for me to be able to sort of make sure that I can keep track and pay the team and not, I can have planning that I can just follow throughout the entire year. And so it just feels so great to have this very stable operation. I don't have to think about search engine optimization. I don't worry about AI slop. Apart from it, just like its aesthetic, like I don't like its existence. But apart from that, I don't think about advertising. I just delete all of the sponsorship ads that come into my email address. And there are dozens every single day. I just ignore it all. And all I do every day, just wake up and think, how can we make our reporting better? So thank you everybody who heard the call, joined the Patreon last year. You changed everything. And, I feel like this is a chance. This should be a glimmer of hope for those of you who are feeling negative about the future of media. There is a way to make media still a kind of a stable operation into this future. And now I would need each individual patron to decide that they don't want to receive space news. And, the great sort of side benefit of this is that for those of you who aren't patrons, you get all of this content ad-free, Creative Commons 4.0, so people can use it for whatever they like. Teachers can use it in their schools. There's no limitation, and that feels good as well. So here's to many more years of this model working. All right, we'll see you next time.